Hey everyone. So welcome back to my SQL interview series. I'm glad you are here today because we are diving into a topic that play a key role in database integrity and performance. That is SQL transactions, locking and concurrency. Whether you are preparing for an interview or working on a real-time database system or just looking to level up your SQL skills, so this session is for you and let's get started. So here what we will cover in this session. First topic is what are the transactions in SQL. Second, we have discussed about asset properties. Third topic is locking mechanism in SQL. Then we move to concurrency and isolation levels. And at the end, real-time examples and some common interview questions and tip to answer them. So let's begin with transactions. So what is a transaction? So imagine you are transferring money from one bank to another. It means this is a bank one and this is bank two. It involves deducting money from one account to adding it to another. So it is deducting from account one and adding this balance into account two. So both action must happen together. Either both succeed or both fail. So that's a transaction, a unit of work that is executed as a whole. If something goes wrong in the middle, you can use rollback to undo the changes. So transactions are essential in banking, e-commerce, ticket booking, basically any system that must maintain consistency. Now let's talk about the ACID properties that define a reliable transactions. So ACID denotes atomicity, A for C for consistency, I is for isolation, and D denotes durability. So atomicity, the transaction is all or nothing. It means everything has been done or not. If any part fails, the entire transactions roll back. Now next is consistency. So the database always moves from one valid state to another. No corrupted or partial update. Third is related to isolation. Isolation, basically transactions work independently even if they run simultaneously. Next is durability. Once a transaction is committed, its results are permanent even if the system crashes. So here we have tip like interviewer often ask you to explain ACID with a real-time example. So remember this money transfer scenario, it's a favorite. Now move to locking in SQLs. So SQL Server uses locks to control access to data and prevent conflict. Let's understand the type of locks. So first is shared lock. So in shared lock, used for read operation, it means multiple user can read simultaneously. Like here user 1 and user 2. So they can read simultaneously. Okay. Exclusive lock used for write. only one transaction can modify the data. It means something has been updated by user 1 and something updated by user 2. So at a time, only one transaction can modify data. Okay. Update lock. So it is a temporary lock used during updates. And this is last not least. So intent lock, it is related to the indicator transactions intention to acquire lock. So why is locking important? Without lock, two user could read and write same data at the same time, causing inconsistency. But beware, too much locking can slow down your system or causes deadlock. Next is concurrency control. So concurrency means multiple user accessing data at the same time. It's great for the performance but can lead to tricky problem like dirty reads, non-repeatable reads, and phantom reads. So in dirty read, reading uncommitted data from another transaction, and in non-repeatable read, getting different values when reading the same row multiple times. And last, phantom read, it is related to new rows appearing between queries. To handle this, SQL Server provide a isolation labels that we will explore next. So, in isolation label in SQL, so each isolation label provide different balance between consistency and concurrency. So these are the different isolation label: read uncommitted, read committed. Third is repeatable read, serializable, and snapshot. So in read uncommitted, yes, here dirty reads involved, non-repeatable reads also there, and phantom reads. So these are the bifurcation for this. So let's say you are building an e-commerce platform. Two users are trying to buy and last piece of a product. Without proper isolation, both might see it is as available and place the order, leading to overselling. So using serializable isolation label prevent this by locking the range of data. In high performance systems, snapshot isolation or read uncommitted snapshot isolation can give you concurrency without compromising consistency. Let's look at the some interview question. What is a transaction? We have already discussed. How is it managed in SQL? Explain asset property with an example. What type of locks are used in SQL Server? What are isolation levels? How do they impact performance? How do you handle concurrency issues in real-time system? So use real-world analogies when answering, like banking, online booking, or shopping cart. So now quick recap. Transactions maintain consistency. Locking protects data integrity. Isolation level manage concurrency. Use begin transaction, commit and rollback wisely. Choose isolation level based on use cases. Balance consistency versus performance. So test these with sample data and observe behavior under concurrent session. So thanks a lot for staying with me till the end. If this session helped you, don't forget to like and subscribe to the channel. Drop your question or interview experience in the comment below. Coming up next, SQL Server deadlock, causes and resolutions. See you next. See you in the next video.